Okay, here we have a setup to determine the actual resonant frequency of the secondary on a very large Tesla coil. In case you ever wondered what it is, what it means. Imagine a swing set swinging. The objective is to push that swing occupant at the proper interval, and you can build momentum that way. Well, the same thing happens with electricity and magnetism. So what happens is you want to push the wave, and it adds itself, and it becomes multiples, and it'll keep building and building and building until you get a very large discharge. Basically, that's the purpose of the coil itself. So again, this is just a simple little 100 megahertz scope, and what I've got is a resistor. Just a little wire wound carbon filament whatever resistor, nothing fancy, as my antenna hung maybe 2 feet away from it. And what that's going to do is, let me touch it here and you'll be able to see it. It'll actually hear the ringing frequency of the Tesla coil. So, second piece of equipment you'll need is a working function generator, basically a signal generator. I've got this one set up to output a square wave, and it's at 15 volts, which is nice. I mean, it's got a little bit of power behind it, which is kind of what we're looking at. Let me start showing what's going to happen here. Right now I'm set at 50 kilohertz, and I'm going to increase it slowly, and you'll notice on this oscilloscope what you're looking for is this. Bang, that's the resonant frequency. You notice how it peaked, and right now we're pushing at 70, it's kind of hard to see, but anyway, 70 kilohertz. That's its primary resonant frequency. Now, if you think music, and you go an octave above this, which is, you'll be able to find its second resonant frequency, but it's not as strong. Let me just keep pushing, here it comes. You'll get a little bit more, probably around the 200 range here. Let me see when I get to it. You start seeing a little bit of a, there it is. Okay, this is its second resonant frequency. That happens to be 218 kilohertz. So basically that's what's going on. Let me go back down to its primary resonant frequency, which is 70, and bam, okay, there it is. So now this is kind of a neat little thing, because just being in close proximity to the coil will detune it. If you notice, what I've done is detuned the circuit to a point where it's not putting out anything. Same thing if I touch the actual output capacitor, or torrid, whatever you want to call it, capacitor, and you'll notice just getting near the thing will change its frequency output strength. Pretty simple. That's how it works. And basically I've got my function generator 1 going to earth ground. I have a ground strip on my bench, and the other one's going in the actually I have it going in the ground of the secondary coil, which goes with entire length and then terminates at the top of the torrid. So that's how you verify or determine resonant frequency. And you also notice on the scope, the scope has a frequency output which is 70 kilohertz. And you can tweak it in a little bit further. The honest objective is to go just a little bit shy of the actual resonant frequency whenever you set up your primary coil, for the reason that a streamer coming off of the coil, the big lightning bolt, will actually detune the coil to a lower frequency. So therefore you want to try to keep it just slightly out of tune, and then whenever the sparks are emitting out of the top of the coil, it will be in tune. It's all about tune. Music, think music, and resonant frequencies and harmonics. That's how it works.